y equals x squared is our base parabola. It's the general one, the one that we can always reference back to. If we look at the vertex form, y equals plus k, we're going to notice that a is equal to 1. Whenever there's nothing written in front of a variable, there's always a coefficient of 1. So a equals to 1. H is equal to 0. There is no bracket, there's no subtractor plus in the x spot. And k is also equal to 0. There's nothing out here saying plus or minus a value. So that matches what we have in our graph because our vertex here is at 0, 0. If we were to make a table of values, x and y, and we said if x was 0, well 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9, and you could continue that on. And that's where the graph has come from. So we have 0, 0, 1, 1, 2, 4, 3, and 9. So I could do my table of values and solve for -1 squared, -2 squared, -3 squared, or we know because it's quadratic that it's going to be symmetrical, a parabola, and we're just going to go over one step each time and mirror it. So -1, 1, -2, 4, -3, and 9, and we have our parabola. Now we talked about the step pattern, and it's created from this base parabola. So again, starting at the vertex, we go over one step, up 1. So there's our first step pattern of 1. We're going to go over 1, and we go up 1, 2, 3. There's our step 3, and we're going to go over 1, up 1, 2, 3, 4, 5. And we have a step of 5. So our pattern here is 1, 3, 5. It would continue on 7, 9, 11. And we'll use this pattern, this pattern, to help us plot other parabolas of this form so that we don't have to create a table of values every single time. So let's look at a few that are, okay. So we have, let's look at this green one here. Our vertex is 6, 7, 8. So our vertex is over 0, the x-coordinate is 0, up 8. We also know that that's our h and our k. It hasn't changed its shape, so if we check this out with our step pattern, if we go over 1, sorry, just seeing the pattern here. So grid lines 1, 2, 3, 4, so every grid here is worth 1. So if I go over 1, up 1, from here I'm going to go over 1, up 3, over 1, up 5, 1, 2, 3, 4, 5. So from this I can tell that it hasn't stretched or compressed. It still has an a value of 1. So I know my a equals 1, my h is 0, and my k is 8. So from this, my formula is y equals, we're not going to write the 1, well, let's just do it, a x minus 0 squared plus 8. Now, that can be simplified, so we have x squared plus 8. Again, if you look at your reference sheet, it has moved up 8 from the positive 8. It has not moved left or right because our h value is 0. It's opening up because a is positive. It has the same step pattern because a is 1. And it has a min value. So the parabola is opening up. So the bottom of the parabola is our minimum value, and that minimum value is positive 8. So if we look at this purple one, we have, so our vertex here is over 5, and it went down to 6. Let's change the color here. Okay. So, sorry, we have 5, negative 6. And let's see what our step pattern creates at this one. So if we go over 1, up 1, over 1, up 1, 2, 3, over 1, up 5, 1, 2, 3, 4, 5. So we can see that A is clearly not 1. It did not follow. Our parabola would have gone up like this if the A value is 1, and that's not the case here. So we know that we're using a different A. So we've got to go over 1, and let's see where it meets an axis. And we're going up 2 in this case. Over 1, up 1, 2, 3, 4, 5, 6. It's gone up 6, and over 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up 10. So if our original step pattern was 1, 3, 5, and this one is 2, 6, 10, we can see that the pattern here is times by 2. So A has a value of 2. If our vertex is 5, negative 6, that is our H and our K. So our formula is y equals 2x, and then you have to decide now, is it minus 5 or plus 5, and minus 6. So we talked about if it was a positive H moving right or a negative H. So we're going to make sure that we're writing negative 5 or subtract 5, so that when we bring it out of the brackets, it's showing positive 5 like we have in our coordinates here. So again, our coordinates said that it was 5, negative 6. So when we write it in our equation, we write it the opposite way. It's going back into the brackets, so negative 5. So the equation of the purple one, oh, and we forgot the squared, is y equals 2 bracket x minus 5 all squared, subtract 6. Okay, we've spent some time exploring different parabolas and what they look like in their movements and their shapes, whether they're stretched or compressed, and how it relates to how it's written in the form y equals a bracket x minus h squared plus k. So now we need to really consolidate and review what each of the variables represent. So a, we said when we identify a as either positive or negative, that's telling us if a is, or if the parabola is opening up or if it's opening down. So a parabola opening up is going to be positive a, and a parabola opening down would have a negative a value. We also looked at the size of a, and if a is equal to or greater, well, if a is greater than 1, let's see, the eraser, there we go, then we're going to say that the parabola stretches, or it's looking thinner, because picture yourself pulling an elastic band up from the top. It's going to look like the two sides of the parabola are getting thinner because you're stretching it up. If a is a decimal, so if a is between, a is between 0 and 1, it's going to get compressed. Or it's going to look like it's a wider one. Again, picture a can being squished. It's going to get wider as it goes out. H we talked about, it represents whether the parabola is getting moved right or left. And K, we said if a parabola is being moved up or down. So when we combine K and H together, that gives us our vertex. And that's always our starting point when we're graphing from this form. We're going to graph our vertex first. We talked about, and we'll go over a couple examples, that when we're given an equation like this, and we're identifying for h, that when we're writing it down in a checklist of given information like this, that we have to take the opposite value of h. So if it said x minus 3 squared, this is our h value, but we have to say h is going to equal to positive 3. If you remember factoring it and solving, it's like when we have to solve, we're going to move it to the other side. It's a little bit more detailed than that, but it has to do with when we solve it, it's going to move over. Okay. Other quick notes, remembering that we always graph or plot x then y. So taking a look at our base parabola.